In this video, we are going to discuss rule number 11, which is trigonometric rule. Okay, you have 6 trigo rules to memorize. Okay, number 1 is derivative of sine x. The answer is cos x. Number 2 is derivative of cos x. The answer is negative sine x. Number 3 is derivative of tangent x, and the answer is sec squared x. Number 4 is derivative of sec x. The answer is sec x tangent x. Number 5 is derivative of cosec x, and the answer is negative cosec x cot x. And number 6, derivative of cot x equals to negative cosec squared x. Okay, this is 6 formulas under trigo rule to memorize. Okay, now let me look at the examples. Okay, number 1. Okay, to differentiate sine 2x, okay, we have cos 2x times 2. How we get this? Okay, first step, we refer from this formula. When we differentiate sine single x, the formula is cos single x. So, when we differentiate sine 2x, it becomes cos 2x. Okay, but we need to multiply by 2. Why we have 2 here? Because after that, we need to differentiate the angle. We differentiate 2x, so we have 2 here. And the operation should be multiplication here. Okay, why from this formula we don't have times anything here? Because when we differentiate 1, when we differentiate x, it will equals to 1. So actually we have times 1 here. But no need to write. Okay, and then from here, after that we simplify. We cannot multiply 2 times 2x here because 2x here is composite function with cos. Means that 2x here is the angle of cos. So what we do is we just bring constant 2 to the front. So we have 2 cos 2x. Okay, the final answer. Okay, example 2. How to differentiate cos x squared plus 1. Okay, the answer is negative sine x squared plus 1 times 2x plus 0. How we get this? Okay, first step, we refer from formula. Derivative of cos single x, the answer is negative sine single x. So when we differentiate cos x squared plus 1, so the answer should be negative sine x squared plus 1. But after that, we need to differentiate the function inside cos. Inside cos is x squared plus 1. So we need to differentiate x squared plus 1. So we have 2x plus 0 here. Okay. Okay, and in between must multiplication operation. Okay, but we cannot multiply 2x and x squared plus 1 because x squared plus 1 actually is the composite function with sine here. Okay, because sine, trigo cannot stay alone. So means that x squared plus 1 is composite function with sine. Okay, so what we did is we bring 2x to the front. So we have negative 2x sine x squared plus 1. Okay. Okay, now look at example 3. How to differentiate tangent e the power of 2x. Okay. First step, we get x squared, we get sec squared e the power of 2x. And then we have e the power of 2x and then times 2. How we get this? Okay, first step, we differentiate tangent. Okay, using trigo rule, if we have derivative of tangent x, we have sec squared x. So when we differentiate tangent e the power of 2x, it becomes sec squared e to x. Okay, and after that, we need to differentiate e to x? We refer from formula derivative of e single x. The answer is e single x. So when we differentiate e the power of 2x, it becomes e the power of 2x. And after that, we need to differentiate 2x. Okay, when we differentiate 2x, the answer is 2. Okay. Okay, after that, we simplify. So we write 2 to the front and then e to x and then z squared e to x. We cannot simplify e to x and e to x here because e to x here is composite function with z squared. Okay, because z squared cannot stay alone. Okay, now we continue with example number 4. Okay, how to differentiate z3x? Okay, the answer is z3x tangent 3x times 3. How we get this? Okay, first step, we refer from formula derivative of z single x. Okay, which is equals to zx tangent x. So now we replace x by 3. So if we differentiate z3x, the answer should be z3x tangent x. But after that, we need to differentiate 3x. Okay, when we differentiate 3x, it becomes 3 here. Okay, but from single x, okay, if we differentiate, it becomes times 1 here. So no need to write. Okay, and after that, we need to move constant to the front. So we have 3 sec 3x tangent 3x. Okay, and example number 5. Okay, to differentiate cosec for x, okay, the step is negative cosec for x, cot for x, and then times 4. How we get this? Okay, first step, we differentiate cosec for x, okay, and then we refer derivative of cosec single x. The answer is negative cosec x, cot x. So when we differentiate cosec for x, the answer should be negative cosec for x, cot for x. And after that, we differentiate for x, so we have 4. Okay, we have times 4 here at the back. Then we simplify, we bring 4 to the front, so we have negative 4 cosec for x, cot for x. And example number 6, how to differentiate cot x squared. Okay. Okay, after we differentiate, the answer should be like this. Okay, how we get this? Okay, first step, from formula, if we differentiate cot single x, the answer is negative cosec squared x. Okay, so if we differentiate cot x squared, we replace our x by x squared. If we differentiate cot x squared, the answer should be negative cosec squared x squared. Okay, but after that, we need to differentiate x squared. So the answer is 2x. So we must multiply by 2x. Okay. For the basic formula, we have single x here. So when we differentiate cos single x, we only have negative cosec squared single x. But actually, we have times 1 here. Times 1 here actually comes from derivative of x, okay, which is 1. Okay, so no need to write times 1 because it doesn't change the original function or original value. Okay. Okay, so from here, we can move to x to the front. Okay, we cannot multiply 2x by x squared because x squared is composite function with cosec squared. So the best way is we bring 2x to the front. So we have negative 2x cosec squared x squared. Okay. So from this example, okay, actually we can refer from this formula. Okay, if we have derivative of sine u, okay, so it will equals to cos u, and then we must multiply by derivative of u here. Okay, if we need to differentiate cos u, we have negative sign u, and then similar to this formula, okay, but at the back we need to multiply by u prime, okay. And then if we want to differentiate tangent u, we have sec squared u, and then at the back must have times u prime, okay. And same goes to number 4, number 5, and number 6. This is when the function is given in terms of u, okay. Or maybe we can write u in terms of fx. So if u equals to fx, so at the back we must multiply by f prime x. Okay, actually similar to this formula. Okay, and also similar to this formula. But this formula is basic formula where u or fx is equals to single x. Okay, so that's why we no need to multiply by any value here. Actually, we multiply by 1 here. Okay, but no need to write multiply by 1 because when we multiply by 1, it doesn't change the original value. Okay, got it? Coming up next, rule number 12, the last rule, composite function and introducing tapi method. Thank you for watching. Stay tuned. Bye. Assalamualaikum.